2 is 3 over 1, right?
Try another one?
I think I just simplified it when I didn't need to simplify it, and I made a really stupid mistake because I simplified it.
I just didn't get the correct answer on anything.
It was like 2a over a. And I simplified
That
it
was
wrong.
not supposed to.
Yes.
Nice catch.
I remember that. Yeah, so close.
I know.
That took
I don't
way too
know.
long.
I knew I was doing it wrong. I was like, but I can simplify it.
I think that one simplifies all the way down to 2. I think that was what it was.
Yeah.
So 2a over a, and then you just forgot to
Ah!
keep going.
I'm dumb. That makes sense. I don't know how I got A out of that.
It's okay. That's okay. Well, because you were thinking 2a and 1a, so we just took it either way. So you have 1a left, right? Like you're just, yeah, it's fine. Our brains sometimes blow up a little bit.
It was like the last. It was like the last question. I'm like,
My brain blew up the whole test. I don't know what you're saying.
Okay. So we're gonna move on. We're gonna learn a few more things today. Now that we know the power rule, we can do some other cool things with derivatives. Because you don't have to do a limit. The circle thing?
Yes, Carter.
The power rule?
The circle thing.
It's what you just did where you take the exponent down.
No.
Yeah. Yeah.
I really like that.
It's nice because even then when you do a limit, you can check it with the power rule because the power rule doesn't use as much algebra, so you're less likely to mess it up. So that if you like get the wrong answer with the limit, you're like, oh, like it may have happened once when I was recording a video for you guys that I did this entire huge limit and I get to it, I'm like, oh man, I messed up somewhere because that's not the right answer.
Velocity.
I'm sorry. Okay.
Haha.
I hate physics.
It's
This is where I'm gonna go wrong.
no, this is so great. Okay, here's the thing. Okay, so we're gonna think about our driving example and the speedometer. Okay, we're gonna think about driving. So I live about 8 miles away from here, and it takes me like 12 minutes to get home. Okay.
Why? You must drive slow.
I zoom home in 30 seconds.
Sometimes it's just like the turn. Anyway. All right. So if I graph that, time would go here, and at 12 minutes, I would be, and this would be like miles, and I would be at about 12 minutes, I'd have gone 8 miles, but it's not linear, right? Like I didn't just like speed up the whole way, and I didn't like start going like really fast. Like it kind of goes right over time. Like I've gone a little bit, and then I kind of slow down because there's like a stop sign on Shepherd Acton there that I have to stop at. Sometimes I have to wait for a minute, and then sometimes actually when I'm coming into town, there are some like older ladies that walk their dogs. Sometimes I think like does your mom walk to work? I saw her one day walking to work, so I made sure to slow down for her. So
We're gonna put those people in
so it's not really linear, right? So this is my position function. This says like at time 1 minute, I could go up to the function and I could say at 1 minute I'm at 1 mile past my house, right? And at time 5 minutes, I'm at 4 miles past my house. And at time 12, I'm at 8
minutes
miles past my house.
Less than 2 was a 1
Hey,
minute.
I forgot my keys at home when I backed up. I don't know.
You backed up like...
Yeah, you're at the stop sign and then you backed up for some reason.
You gotta
This
get a
does
running
happen,
start.
actually. I have a stop sign at the end of my road. I'm not too far down the road, like maybe a quarter of a mile. And sometimes I'll be like, and so if no one's there, I will back up sometimes. But usually I'll just turn around and go back. But that would still be my position, right? My position would still be closer to home. So this,
I didn't follow that story at all.
it's fine. Don't worry.
You're like, ooh, I'm like, what?
Sometimes I forget and I have to back up into my house because I forgot something.
Oh, I thought you meant you forgot the stop sign
Yeah,
was there, so you backed up to go to the stop sign.
And then I just backed up and stopped
What?
and then kept going.
That's what I thought you like zoomed past the stop sign and then it was like, oops. I was like,
That's why I was like, what?
Sorry.
Well, why like at the very end you go backwards way?
Yeah, that's great, huh?
you passed
I really should make these more precise because you guys are too smart to like notice these things. Okay.
I would not have noticed.
So this is my position function, right? This is my position. So this is like where I am at any given point, right? I put in a time, I get out of position, right? What if I did a line tangent to the graph graph right there. What would the slope of that line tell me right at that point?
Instantaneous velocity.
Instantaneous velocity! Look at that. So it's going to tell me how fast I'm going at that exact moment.
I hate these.
The line tangent to the graph is going to tell me how fast I'm going at that exact second. So here I'm going kind of fast because I'm running late. And then all of a sudden I remember that I'm like on a residential street and I slow down, right? You see that like the slope of this line is really steep, and then I kind of slow down and I don't know what I do here, and then I go fast. This is when I see like the old ladies on the road, I like slam on my brakes to make sure that they don't hit their dogs. Okay, right? So this is the position function.
Position function.
And then the derivative of this function is my velocity. So the derivative at this point is my velocity, right?
Yes.
And then the derivative at this point is my velocity at that time. And then the derivative of that is this.
So the derivative is the instantaneous.
Yes.
The derivative is the key.
Okay, so my derivative,
You can't go up the key.
my derivative is my instantaneous velocity at any given point. But I could graph that. I could graph my derivative. And at any point, I could say, okay, at time 10, what's my derivative of this? That's how fast I'm going at time 10. At time 4 minutes, how fast am I going? I find the derivative at 4, and that's my derivative, or that's my velocity at that point, right? So if this is f of x, f prime of x is my velocity function. So if I want to figure out how fast I'm going, I find the derivative of my position function.
This is going to get so confusing.
And then I just...
No, for next period.
So, because velocity is my rate of change, right? It's how fast I'm changing at that moment. So the rate of change at this point is my derivative.
Okay.
That makes sense.
Each point is a different.
Because it's
different spot you
instantaneous
can take
velocity.
the
It's at that
But how do you
instant.
find?
If this is a function, then I could take the derivative of the entire function.
And that would still get you the velocity.
That would still get it would give me an equation for my velocity, and if I want to find the velocity at a certain point, I just plug in that time.
So if you find like derivative,
So
That would be
Of the
like
function.
algebra. We would just
you
do
just
algebra.
plug in the time. Sorry, go John. Go.
so you get the derivative of the function and then plug in wherever you were at the time.
Exactly.
Oh, okay.
Exactly, because well, this is kind of an irregular function that would be really hard to write an equation for. The majority of the time we're talking about a particle moving in space, we're talking about gravity where it's like dropping, right? Those are constant, they're not constant functions, they're not constant functions, but they are consistent, right? So like we have an actual function, we can take an actual derivative of that. Now here's the question. The velocity is my derivative, right?
Right.
What if I took the derivative of my velocity? What is that telling me?
It's the velocity of your velocity.
My instantaneous rate of change of my velocity.
That's
So you just
my
What's the
doesn't make it. Doesn't work.
instantaneous rate of change? Like
Burn it all!
So you just do it
Yeah,
twice.
just like
Instantaneous rate of change of position is velocity. But what would I call it when I say how fast is my velocity changing? What is that called? Acceleration.
Whoa!
I know it's acceleration. When my velocity is changing, I'm either accelerating or I'm decelerating, right? Like I'm changing my velocity. That's acceleration. So get this. So the second derivative is the acceleration.
Thing is deceleration.
Is it just negative acceleration?
Yeah.
Okay, there you go.
But it's on the coordinate plane. Your negative depends on the coordinate plane. So if it's always going positive, then it's positive. That's the rule.
Confuse people.
Maybe deceleration is going backwards.
Your science teachers are gonna. Okay, this is really cool though
We
because
just
like
got
right
done with
now
this.
you're not doing calculus-based physics or anything, but at some point people actually use calculus to figure this stuff out, which is like really cool.
I really hope I never have to take physics again.
I
Even though I
It's
will
so
have to take
funny.
physics.
That's the opposite. When I was in high school, I was like, I can't wait to take calculus-based physics, and then I never did.
I hate
What is-
You hate physics?
I hate physics. I love calculus, but I hate physics.
Okay.
Why do you love calculus?
So,
Physics is better
You're
than
whack.
this.
Better at it than I do at physics. I'm really bad at it. I don't know why.
Just not this.
okay. So, the position function would be your f of x, right? It's your regular function, right? This is f of x. Then, we differentiate to get velocity. So, f prime of x, you could write differentiate up there, but I can't reach to write differentiate up there. You differentiate to get f of x, f prime of x, which would be your velocity. And then we differentiate again to get f double prime of x, which is our acceleration. So this says the position function gives the location of an object at a time. So basically, if I put a time in there, if I say at 2 minutes, where is this object that we're talking about, it will give me a position. The velocity function tells me the rate of change of the position. How fast is it going at that moment, right? So the derivative is going to give me my velocity. How fast is that particle moving in space? And the acceleration is the rate of change of the derivative of velocity. So how much is the velocity changing? You know, are they like stepping on the gas or not? What?
Newton.
We're going to build a time machine and go back and like mug.
Newton did come up with, like, he discovered most of calculus.
No. Well, then
And
I'm going to
like-
go back in
Isn't
time
there
and
like
give him a
3
bunch of
people that
concussions so he can't
Yes.
remember
At the same
everything.
time? I'm
Yeah,
going to build a
she-
time machine and mug
Mrs.
all 3
Carpenter
of us.
explained this like last week.
Or you could just kill him.
Yeah.
and
Just took
then
a
solve
test
all
on it.
the
Because
world
it's all has to
problems.
do with the universe and because we need curves and stuff, so that's why we invented calculus.
So it's really, I mean, it's not so, it's not like someone just like made this stuff up. It's that they looked at patterns that were happening in the world and they made notation to
Unless
explain
you're really smart, you don't need
that.
Like,
And now
space
smart
travel
people
is
invent
like the only
Facebook.
thing.
But who do, I mean, in 20 years, we like have no idea what jobs you guys are gonna do, right? Like, we're training you for jobs that don't even exist yet.
That's what
Yay.
my calculator and
I
computer
want to
will
be a
do.
business.
Okay,
Pretty soon I'm gonna take
So,
a picture of the problem. It's
a
gonna be-
lot of times, instead of writing f of x, we're gonna see things like s of t, x of t, y of t. We're gonna see things like that because when we're talking about position, velocity, and acceleration, we're talking about time, right? We're putting a time in there to find out how fast it's going at that time, how much it's accelerating at that time, or just where it is at that time. So our initial position would be at t equals 0, right? At time equals 0, that's where we start. So if you put t equals 0 into your original function, it will tell you your initial position. Sometimes we'll use this notation, s naught, or s of 0. That little 0, have you guys seen that before where you use that? We call it f naught sometimes. Okay, starting velocity would be when we put t equals 0 into our velocity function. Okay, here's an important distinction, the difference between velocity and speed. Speed is the absolute value of your velocity. So speed is basically just the positive version of whatever you're going. So if you have a negative velocity, your speed is still positive.
I can get rich off this idea.
Does that make sense? Speed is just the positive value version of whatever your velocity is.
But isn't speed just like average?
Not in this case, no. Speed is just another word for velocity. We're just talking about the absolute value of your velocity.
They could just move it to any circle.
And then isn't
Care what
displacement the
direction.
speed but with like
Say, I
a
want this
direction?
tattoo this week.
Yeah, so velocity is a vector, meaning it has
Like arrow.
direction and velocity. It has speed and direction. So velocity is saying I'm going this fast in this direction. Speed is just saying I'm going this fast. It doesn't really matter which direction you're going. It's just saying I'm going this fast.
Displacement centers have gone this far.
Yes, awesome. So displacement is the net change in position. So you figure out where you started, right? So like my displacement, if we were talking about from school to home, my displacement would be 8 miles, right? 'Cause it
Placement is
takes
the
me-
easiest, I like that.
Yeah, it's just 8 miles from where I started. If this was 0.0 and that was 0.8, or that was 0.0 and that was 0.8, it took me 8 to get here, 8 miles, okay? And then the total distance traveled though, so imagine this, I start at home, I get all the way to school, and my kid calls and they forgot a super important thing, and I drive into Independence and I drop it off, and then I drive back out here. Although I'm still only 8 miles away from my house right now, I'm hypothetically only 8 miles away from my house, what's my distance traveled? A lot more than 8, right?
But your displacement's still 8.
Displacement is 8, but my distance is whatever I traveled. So it's like the 8 miles here, the 10 miles to school, and then the 10 miles back, whatever it is.
So there's like instantaneous displacement then?
What?
No.
Well, I mean,
No.
that'd be easier.
This displacement and distance deal just with our position function. We're just talking about our original functions.
But there's instantaneous acceleration.
X, what is Y?
Right? Or is that just the acceleration?
Acceleration is instantaneous velocity.
Plug it in your calculator.
So velocity is our first derivative. Acceleration is our second derivative, and that's basically our instantaneous velocity. Like how much are we changing at this exact?
So is the acceleration the like double prime? Double prime.
Yeah, acceleration is double prime.
So is that just like normal acceleration? Just like the average
Yes.
acceleration?
It would be acceleration at that exact moment. So it's
So
it's
it's like
instantaneous
instantaneous
acceleration.
acceleration. Okay.
Yes, you're right. You're right. It is instantaneous acceleration because it's at that exact moment. We're not talking about average because, you know, I could say on average it took me, you know, I was driving about 60 miles an hour from here to home. But the reality is from here past the 25 mile an hour, I was driving 25. And then when I got on the rest of Shepherd Action, I was going like 75. The speed limit's 60, I think. But so my average over time, you know, if we did average, it would be about 60 miles an hour or something like that. But
So you could just use algebra to find that average
algebra would just,
acceleration.
yeah, you find your change in x, or change in y over change in x. Like how far did I go divided by how long it took me.
Go get a code art.
I have
All right. Let's figure out how to do this with calculus, okay? So we have a function here, and let's imagine that this is a function, this describes the movement of something in space, okay? So this is our position function. S of t is our position function, okay? Then when you see v of t, that means find your velocity. A of t means find your acceleration. But we also know that this means position, this means velocity, this means acceleration, this means f of x, f prime of x, f double prime of x, right? That's all we're doing. We're just finding derivatives. We're just applying it to something in real life. Okay, so v of t is really s prime of t, right? We're finding the derivative of the first function, of our position function. So it would be 3t squared plus 1.
Oh, that's cake.
Right?
But
It's
is it
gonna get way
hard?
worse.
Ha ha ha.
Okay. Acceleration, what's the acceleration?
6t.
6t, because it's the
not
second
60,
derivative. Okay,
80 equals 60.
that's it. So if we said, what, at time 2, what's the position, what's the velocity, and what's the acceleration, we would just put 2 into each of these functions and figure out it's at this position, it's at this velocity, it's at this acceleration. Okay?
What's the catch?
What's the catch?
Yeah, it's
Just
gotta
some
be hard
applications.
dimensions.
Okay, so we're going to use this position function. This is a position function of an object moving on a horizontal line. Distance units are measured in feet and time units are measured in seconds. So it says
24.
the initial position of the object.
24.
Why?
Because you plug in 0 for t.
Right. Initial position means when time equals 0, where am I at? When time equals 0, those two go away and all I have is 24. So it would be 24. So I would say S of 0 to show that I knew what I was doing, that I wasn't just guessing a number, right? I'd say S of 0 equals 24.
You're still right.
Not seconds, we're at feet.
Just a good guesser. Dude, I wish I'd never guessed wrong.
Okay.
That would be awesome.
That would be awesome. I swear I'm like the worst guesser though. Like I'm one of those people that they're like, oh, you should get about 25% right if you guess, right? No, 10% maybe. Maybe. I'm like the
That's what I
worst.
do in the ACT. I'm like guessing. I'm like, that's what
I know.
Yes.
I know. My husband is like a great guesser and cheater. I'm like it's more work for me to try to guess or cheat than I just figure it out. So I can't, because my guessing is going to be bad. Okay, what's the velocity of the object at time equals 1? So first we need the velocity function, right? We have the position function, now we need the velocity function. So v of t
16 times
equals 16 times 3 is 48. T squared minus 72 t, and then the 24 goes away. So that's the derivative, right? That's the velocity function. And then all I do is plug 1 into there.
Yeah.
So I say v of 1 equals,
48 minus 72.
which is
Negative 4. Something.
24.
negative 24. And then what are my units?
Second.
Feet per second. Feet per second. We're talking about velocity. How many feet per second, right? That's how much it's changing. So,
Seconds per feet.
feet per second.
No, it's funny.
That's my velocity. So the next question is, what's my speed at time equals 1? It would be, because velocity cares about direction. So velocity can be negative or positive, right? Velocity is a vector. It's telling me I'm going this way or I'm going this way, right? Speed doesn't tell me where I'm going. It just tells me how fast. So speed is going to be the absolute value of my velocity, which is just 24 feet per second.
That's not bad.
It's not bad, right?
I hate physics.
Okay.
But when we add calculus to it, you might like it a little bit.
A little bit, but it's still just like talking myself through it. I just keep talking myself through it.
Same.
But she likes to like cut open cadavers. See, like everybody has different interests,
Yeah,
right? Like the
that's
idea
different
of like saliva even grosses me out. Like any bodily function, I'm like,
Yeah, same with my sister, and then she said she wanted to be a nurse.
Ooh. Everyone kept telling me to be a nurse when I was going to be a teacher. I was like, no. I loved teaching, that's why I did it. But the idea of like sticking someone with a needle.
That's what the nurses do. I
Wow.
don't want to be a nurse. Because
She wants to
growing
stab
up,
people.
everybody
She wants a needle
was
that's
like, you should be a nurse. So now I just
Bryn's
blast
gonna
them with
stab
music.
people to life.
Bryn,
Yes.
please don't
Yes.
kill me.
My backup plan is to become a serial
This
killer.
weekend.
How do you make
And she's
money?
gonna take care of
Carter's my
people
first victim and Nate's my second.
Oh, I don't know when Carter disappears. I can
Oh, wait, what did you say?
Okay. Accelerate. See if you.
Her backup plan.
They're
she's
learning to pay
serial killer,
attention
you're the first
because they're
victim, and
missing out on
Hey,
great
Brian, guess
conversations.
what?
Okay, acceleration.
You weren't the first.
Acceleration. What?
I'm not saying.
Here's our position function, our velocity function. So our acceleration function is
One more.
96 t
What's
minus
48
1.
times 2? 48 times 2.
So it's just
96.
96 minus 72 is just 24.
Minus 72, that's 24.
Meters per second squared.
Feet
A of 1 is 96 minus 72. You guys said is 24
Feet per second squared.
per second or feet per second squared. Yeah.
Because I like to say.
When is
math
the
like
object
meters
at
per
rest?
second.
Never. 0. Wait, no, it'd be 24.
So-
Okay.
Never.
When is the object at rest? What does that mean?
Not moving.
When is
Not
the-
moving. So the velocity is?
Zero.
Easy as that.
So the first derivative is 0, which means it's got a horizontal tangent line. So when, at what point does our original function have a horizontal tangent line? That means its velocity is 0.
Negative 24.
Okay, so when is velocity of our velocity function 0? So we take this, 48t squared minus 72t, and we set it equal to 0.
Oh, what? Damn.
We get 24t times 2t minus, is that 3? Yeah.
Would you just take the 2 out first? Or the 2 out first? What? No, mind.
You need to take the greatest common factor out, and so you take the t and the 24 out.
0 and 2/3.
So at 0 seconds, it's not moving at all, right? Because then the product, the 0 product rule, I think is what it's called, it basically says either this factor has to be equal to 0 or this one has to be equal to 0. So 24t equals 0 or 2t minus 3 equals 0. So So this would be t equals 0. At time equals 0, we have no velocity. But also, at time equals 3 halves.
1.5.
At time equals 3/2 seconds, we would have the velocity would stop. It would stop for just a second and then it would keep going. So if we looked at this graph, this graph would have a max or a min at that point, right? Because at that point it would like top off where our tangent line would be parallel to the x-axis. So we'd have a horizontal tangent line at these two places.
So it's both of them?
At both of them, yeah. At t equals 0 and t equals 3/2. Okay.
You just have to write t equals 0 and t equals 3/2.
Yeah, seconds. You should write seconds in there. See that little like scribble at the end? That's my seconds.
We love me.
Okay.
This is better than physics, because physics you just like use the same equations, but yet I plug it in wrong somehow. So.
Okay. When is the object moving right?
When it's
don't know.
positive.
When it's not moving.
So yeah, remember that velocity has direction and magnitude. Direction and magnitude. That's a
That's
vector.
what I was saying.
And I laughed at you because it was weird.
Vector. Vector. You know.
Off of this big
Because
one.
it has direction and magnitude.
I just realized right
Yeah. Thank
No.
you.
Vector. Velocity is a vector, which means it has direction and magnitude, right? So it's
Yes.
telling us how fast it's going, but it's also telling us whether it's going left or right.
How?
Positive or negative.
But it doesn't.
So if our
It doesn't
velocity,
say whether right is positive
Yeah, but
or
we
down,
didn't
though.
define
X and
it.
Y.
There is
I
no
mean, X.
coordinate
It's
plane,
the X
therefore we
coordinate.
cannot
How do you
know.
know that?
Because
Did not
X is
define
right
it.
or left. Y is up or down.
But what if it is up or
What
down?
if, what if I switch my right to my left?
okay.
And what if I don't have any
That's
hands?
right. Okay. So, when our velocity is greater than 0, it's moving to the right, okay? Because the velocity tells us direction. So velocity it will be going to the right when it's greater than 0, it's going to the left when our velocity is less than 0, okay? So the question is, when is our velocity greater than 0? Well, we know it's equal to 0 at these 2 points, right? So we know it probably changes from going like positive to negative or
Oh, is this
negative
like
to
a limit?
positive at these points. Not necessarily, but we kind of do a little sign analysis here. So let's think about when velocity equals 0 and velocity equals 3/2, okay? So when velocity, or at time, sorry, when time equals 0 and time equals 3/2. Cotton picking board, okay. So, when time equals 0, what is our velocity before then? Let's look at our velocity function. Our velocity function is this one, right? So let's plug in like -1 to that, and what happens?
I give -1 second.
It becomes positive.
So it's positive 48 plus 72, so it's positive. So over here, when we plug in negative values into our velocity function, it's positive, right? So our
How can you plug in a 1 though, because it's time?
How do you have a negative in time?
You can't go negative time.
we have a time machine. We're
You
hard to
can.
apply.
technically.
What?
I hate life.
If you
That move is fake. We don't have flying cars in 2016.
Did you guys watch?
2019
Did you
is
watch it
not
on Back to the Future Day? Did you watch Back to the Future on the
Yeah.
2015? Like it was like October something, 2015. Sure.
It was 2016.
It was 2016. Thank you. I watched it with my kids, and then I forgot how bad it was, and I kept being like, "That's a bad word. Don't listen to that. What they said. Close your eyes." Okay. So in theory, if we could go back in time, our velocity would be positive back there, right? What happens when I plug in 1 in here, in between these two zeros? What happens?
negative 24. That's
Yeah, so this is
Yeah.
negative. In between 0 and 3/2, we've got a negative value. Right? So our velocity is still negative, which means our particle is now moving to the left. Okay? Because our velocity is negative, so that direction part of our velocity is telling us we're moving left.
I got it.
When we put a number bigger than 3/2 in, which way are we going?
Positive.
Positive, because it'd be like
That would be bigger.
2. Then this one would be bigger than this one. If we put a value bigger than 3/2, then the 48 becomes bigger, and now we have a positive value.
I like that.
Okay?
You like that?
So at what point is the velocity positive? Greater than 3/2 or less than 0. I understand that you can't have a negative time, but in math,
Subtech.
less than 0 does exist, right? So we'll say that that it's there.
We still have no.
So
Whatever.
Wait.
when t
I
is
broke
less
it.
than 0 seconds, or when t is greater than 3/2 seconds, our particle is moving right because our velocity is positive. So then when is it moving left?
It's negative. So
All the other times? Yeah. So in between 0 and 3/2, we figured that out. In between 0 and 3/2, our velocity is negative. Negative velocity means it's moving to the left. There you go.
Wouldn't it be equal to though too?
No, equal to the velocity is 0, so it's not moving at all.
Man.
At 0 and at 3/2, it is completely stopped. So it's not moving at all. Okay? We'll stop there. It wouldn't hurt you to look at some of the homework problems at the beginning to see what you can do. Tomorrow we'll learn the rest and then work on questions and stuff like
I
that.
don't like math anymore. It doesn't make sense. It's
You got negative time.
It's
Stupid
not
physics.
common sense.
I'm just gonna go back in time because that makes